What are the challenges in creating robust RL simulation environments? Imagine trying to teach a robot to navigate a busy street or a self-driving car to handle unpredictable traffic. Creating the perfect simulation environment for reinforcement learning is no small feat. It's like trying to build a miniature world that accurately reflects reality, but with many hurdles along the way. One big challenge is sample inefficiency. Reinforcement learning agents need tons of data to learn effectively. Even in simulations, gathering enough interaction data takes a lot of time and computing power. When you try to move from simulation to the real world, this gap widens because the agent might not perform well outside the controlled environment. This means more real-world testing, which can be costly and slow. Another issue is the simulation-to-real gap. Simulations often can't perfectly mimic real-world physics like friction, lighting, or how objects interact. These small differences can cause the trained agent to fail when faced with actual conditions. To fix this, developers use techniques like domain randomization, where they vary simulation parameters to expose the agent to many different scenarios. But this adds complexity and increases the time needed to train the agent. Designing reward functions is also tricky. Rewards guide the agent toward desired behaviors, but if they are poorly set, the agent might learn to do unintended or unsafe things. For example, rewarding speed might make the agent ignore safety. To prevent this, developers often include multiple objectives or human feedback, which makes the simulation setup more complicated. Environmental complexity is another hurdle. To prepare agents for real-world variability, simulations need to include many obstacles, dynamic elements, and larger spaces. But adding complexity increases training time and demands more computing resources. Too simple, and the agent won't generalize well. Too complex, and training becomes impractical. Safety and reliability are critical concerns. Since reinforcement learning involves trial and error, an agent might try risky actions during training. Simulations need to include safety constraints and failure modes to teach the agent to avoid dangerous behaviors. But modeling every possible real-world failure is nearly impossible, making it hard to ensure safety in all situations. Finally, balancing exploration with practical limits is a challenge. Agents need to explore to find good strategies, but in real life, exploration can be dangerous or expensive. Simulations should encourage meaningful exploration without risking harm or wasting resources. In real-world applications like autonomous vehicles or robotic arms, these challenges matter a lot. For example, simulators like Carla try to model driving scenarios but can't capture every physical variation. This can make the trained policies less reliable when applied outside the simulation. Similarly, robotic simulations must accurately model contact forces to prevent failures when moving to real hardware. All these challenges show why creating effective reinforcement learning simulation environments is a balancing act. Developers need to make them realistic enough to train robust agents, but also manageable in terms of time and resources. It's a careful process of designing environments that prepare agents for the real world while keeping safety and efficiency in mind.